The increasing order of boiling points of CO2, SO2, N2, He and Ne is. Figuring out the order of boiling point is all about understanding the trends. The key thing to consider here is that the boiling points reflect the strength of the forces between molecules. The more they stick together, the more energy it will take to blast them into the atmosphere as gases. There are three important trends to consider. The relative strength of the four intermolecular forces is ionic bond is the highest, then hydrogen bonding, then dipole-dipole interaction. The least one is the London dispersion forces. The boiling point increase is the number of carbon is increased. The third one, branching, decreases the boiling point. So these are the factors affecting the boiling point. So basically helium and neon are monoatomic. So the London dispersion forces depend on the size of the molecules. Because the noble gases are monoatomic, the intermolecular forces will be extremely weak. So there is a weak interaction between atoms of noble gases, leaving a low boiling point. And an important point to note is that the molecular forces increases with the atomic size, and that's why helium has lower boiling point than the neon. Nitrogen is a diatomic non-polar atom, which is the London dispersion forces is the intermolecular forces. Due to its weak London dispersion force, it has a low boiling point, and due to the fact that it is a diatomic, its boiling point is a bit higher than the helium and neon, because helium and neon are monoatomic. CO2 molecules also have London dispersion forces as the intermolecular force. But due to the size and the mass of the CO2, the number of intermolecular forces are high compared to helium, neon and N2. But the molecular geometry of SO2 is bent, therefore SO2 is a polar molecule. Due to that, it could make dipole-dipole interaction. So basically dipole-dipole interactions are much stronger than the London dispersion forces, and the mass of the SO2 is higher than the CO2. So due to these facts, the boiling point of SO2 molecule is higher than of CO2. So the answer is